So good evening, all of you.
Good evening, sir.
Good evening. Good evening. So good evening. Good evening. In last lecture, we were discussing about Thevenin's theorem, and in this theorem, any two terminal network can be replaced by an single loop network having a new voltage source VTH and series resistance RTH. So that is the Thevenin's equivalent between point 1 and 2. And if you know VTH and RTH, you can find current through any load. And if you know current, you can find voltage. VTH we have defined as open circuit voltage. So because these are the two terminals, so this is the load. So you should remove the load and measure this voltage. That is open circuit voltage or Thevenin's voltage. Okay? And what is RTH? RTH is equivalent resistance, Thevenin's resistance, that is equivalent resistance at the terminals when the independent source is turned off. And you know the meaning of turned off means voltage source will be short circuited, current source will be open circuited. They are replaced by their internal resistances. Is it clear what will be the Thevenin's equivalent and how to find VTH and RTH? Clear?
Yes, sir.
So now we will take some examples. This I have already discussed. Now take example that I am taking same two loop network that we have discussed in KVL, KCL, and also in superposition. So when you have more than one source, that case was the superposition. Now take example. Let's say this is 12 volt and this is 3 ohm. This is 3 ohm. This is 6 ohms. Then you have 7 ohm and this is 7 ohm. This is also 7 ohm. Now assume, let's say you have to first find this current I1 and then you have to find I2 also. But now you have to use Thevenin's equivalent. Using Thevenin's theorem, we have to find current I1 and then I2. So for I1, two terminals are 1 and 2. And for this terminals are, let's say, 3 and this terminal is 2 itself. This terminal will be 3, 2, or you can take 3, 4. 4 and 2 are same. I am taking this to be 3, 4. So for current I1, what will be equivalent for I1? Thevenin's equivalent for I1 means load is 7 ohm. So you have VTH1, RTH1 across the load. This point is 1 and this point is 2. This will be 7 ohm and this is 3 ohm and this current is I1. No, this is RTH1. This is the equivalent. So we have to write this as RTH1. This is RTH1. So if you know VTH1 and RTH1, then you can find the current I1. So let's see what will be open circuit voltage in this case. Open circuit voltage. This will be 12 volt. This is 3 ohm. This is 6 ohm. And This will be 7 ohm, 3 ohm, 6 ohm, and this is 7 ohm. This terminal is 1 and 2. Now this voltage is VTH1, open circuit voltage. By definition, you have to find open circuit voltage. So let's calculate that voltage. Open circuit voltage means these are the two terminal. So remove the load and measure this voltage. So there will be no current in 7 ohm. Open circuit means infinite resistance. So no current will flow. So current will flow in this loop only. Let's say this current is I dash. So VTH1 will be I dash into 6 ohm. And I dash is 12 volt by 3 plus 6 into 6. And that will be given by 12 by 9 into 6. So this is 8 volt. So this you will get as 8 volt. ठीक है? And what is RTH1? This is the equivalent resistance when independent sources are turned off. So this is short circuited. This is 1 and 2. This will be 3 ohm. This is 6 ohm. And this is 7 ohm. This is the Thevenin's resistance. By definition, that sources are turned off. Voltage source will be short circuited. If there was some current source, it will be open circuited. So what will be equivalent resistance? Just check here. These two are in parallel. 6 into 3 by 6 plus 3 plus 7. So this will be 2. This is 9 ohm. So this is 9 ohm. So what will be current I1? I1 is given by VTH by, this is 8 volt, 9 ohm plus 7 ohm. 16. So half ampere. And using KVL also we have calculated half ampere. So just check the value, whether it is correct or not. Clear? So we have calculated current I1 using Thevenin's theorem. Now let's see, you have to find I2. So we have to write Thevenin's equivalent for I2. For I2, this will be, now you have a new voltage source VTH2, and this is RTH2, and then this will be across point 3 and 4, and that will be 6 ohm. So this current is I2. This is the Thevenin's equivalent. Now you have a new voltage source VTH2 and RTH2 is the series resistance. Okay. So again, what will be VTH1? Just check. VTH2, this is 12 volt. Then this is 3 ohm. Now this will be open circuited. Now this 3 and 4, This is open circuit voltage. Seven ohm and 7 ohm. This is VTH2. So what will be this drop? Either you should first find the current in this loop. Let's see, current in this loop is I double dash minus plus plus minus. This is the actual direction of current. So what will be I dash? This is simply Ohm's law, V by R equivalent. So 12 by
17.
yes. So I double dash will be 12 by 14 plus 3, 17 ampere. This will be the I double dash. Now you have to find this value. So I am considering this particular loop. In loop 1, if you apply KVL, you will get minus 12 volt. Just everything is in voltage plus 3 I dash plus VTH2 is 0. Then VTH2 is 12 minus 3 into I dash. What will be this value? You should take 12 common. So this is 17 minus 3 by 17. So this value is 12 into 14 by 17. This much volts. So this is 12 into 14 by 17 volts. And what will be RTH2? Equivalent circuit for RTH2. So voltage source will be short circuited. This is short circuited. 3 ohm. 7 ohm. This is also 7 ohm. 3 ohm. 7 ohm. This point is 3 and this point is 4. So this is, by definition, this is RTH2. So if you see equivalent, what will happen? Now these two are in series. So RTH2 is 14 into 3 by 14 plus 3. So this is 14 into 3 by 17 ohms. ठीक है? This is 14 into 3 by 17 ohm. Now you know VTH2, RTH2, so you will get the current. So current I2 will be given by VTH2 divided by, so this is 12 into 14 divided by 17 by 14 into 3 by 17 plus of 6. So this is 12 into 14 by 17. This is 17. 42, 144, 102 and 42. 144, this will cancel out. 12 times 14 by 12 is what? 7 by 6 ampere. And we have calculated same value using KVL also. So just see Thevenin's, we are verifying the Thevenin's theorem, whether it is correct or not. So with this example, you can see from KVL also you got same result, and from using Thevenin's theorem also you got the same results. So this is the method of Thevenin's theorem.
सर RTH2 है ना, इसमें सर ये सीरीज में नहीं होंगे?
नहीं, this is the point ना. So these two are in series.
Yes sir.
So 14, but point is this, So
Yes,
what
sir.
will happen? So this is 3 ohm, and then these two are in parallel. If you draw equivalent for this, you will get, let's see the equivalent. This is 3 ohm, and this side you have 14 ohm, and this is the point. This is 3 and this is 4. So these two are in the, about these 2 points, they are in series or parallel?
Parallel, sir.
Parallel. So
Yes,
these
sir.
two are in series, and that is in parallel. Just connect a voltage source between them. If you want to check, let's say you have some voltage source V dash. So you will see this voltage is same, and there will be a current division here. Voltage will be same. So in parallel combination, voltage is same. In series combination, current is same. Okay?
Yes, sir.
Is it clear?
Yes, sir.
Okay. Note it down. We are going to use all these theorems when we will study different topics in diode, transistor, op-amp. We are going to use all those things: KVL, KCL, superposition, Thevenin's theorem, and so on. Some when you can convert a voltage source into current source using Norton theorem also. Is it clear? Can I take next example?
Yes, sir.
Chalo. Now I will take case of a 2 voltage source, and again you have to apply Thevenin's theorem. This is 12 volt. This is 3 ohm. This is 6 ohm. Let's find this current. Find current I using Thevenin's theorem. Let's calculate. First draw this voltage is 6 volt. This is 6 volt. Try to find current I. So according to Thevenin's theorem, what will be equivalent? These are the two terminals. So you have, let's show the terminals first, 1 and terminal 2. So equivalent is you have a series resistance RTH, and you have a voltage source VTH, and then you should connect the load resistance. Load resistance is resistance in which you have to find the current. Clear? So if you know VTH and RTH, you can find the current just by writing VTH by RTH plus 6 ohm. So what will be VTH? You have to VTH is what? Open circuit voltage. This is 12 volt. This is 3 ohms. This will be open circuited. Point number 1 and 2. This is VTH. You have to find this value. Now assume this current is I dash. Let us first find the current, because if you know current, only then you can find the VTH. I am showing the polarity, and I have assumed this to be the direction of current. So if you apply KVL in the complete loop, apply KVL, Kirchhoff's voltage law. So you will get minus 12 volt plus 3 into I dash plus 7 into I dash plus 6 volt is 0. So 10 I dash is 6. I dash is 3 by 5 ampere. This is 10 I dash is equal to 6. So this is 3 by 5 I dash. Now, if you know this current, you can apply KVL either in this loop or in this loop. Both will give you value of VTH. So let's apply in loop 1. A smaller loop. So you will get minus 12 volt plus 3 I dash plus VTH is 0. So what will be value of VTH? This is 12 minus 3 I dash, 3 by 5. 60 minus 9, 51 by 5 volt. So VTH is 51 by 5 volt. Clear? Now find RTH. Let's calculate the RTH value. Calculate the value of RTH. Try to find RTH.
So 21 by 10.
Okay, let me check. Let me check this. So RTH, you have to short both voltage source. This will be short circuited. And this is 1 and 2. This is 7 ohm. This will be short circuited. And this will be RTH. So again, what will be RTH? These two are in parallel. So 3 into 7 by 3 plus 7. So this is 14 by 10 or 7 by 5 ohms. No, 21. So this is 21 by 10. 21 by 10 ohm. So this is 21 by 10 ohms. Now current I is given by 51 by 5 volt. Divided by 21 plus 10 plus 6. So this is 51 by 5 into 10 by 681. So what will be this value?
So 34 by 27.
34 by 27. I think we have calculated same value. using superposition as well as using KVL, KCL? Yes or no?
Yes, sir.
So using Thevenin's theorem also, we have verified the result. Clear? Is it clear to everyone?
Yes, sir.
Now, let's see one last example based on this. Can I take next slide?
Yes, sir.
Now, you should try to solve it. So this is this value is 20 volt. Then you have 8.2 kilo ohm. This is 8.2 kilo ohm. Now you have 2.2 kilo ohm. And this value is again a 20 volt. This is given, and there is a, let's take it as 1.3 kilo ohm. What will be this current I? Now try to solve it. What will be current through 1.3 kilo ohm resistance? So again, Thevenin's equivalent is same across terminal 1, 2. This is VTH. This will be RTH. And this point is 1. This point is 2. So this is 1.3 kilo ohm. Now this current is I. Now let's find VTH and RTH. Try karo. Try to find VTH and RTH.
This is 8.2 या 82 kilo.
VTH. This is 8.2 kilo ohm. This is 2.2 kilo ohm. So let's see what will be VTH. Equivalent for VTH. So this is given by 20 volt (8.2K) and this will be 1 and this is 2. This is 20 volt and this will be VTH. So if you want to find VTH, let us first find this current, I dash. So this is minus plus, plus minus, this is the polarity. And if you apply KVL, what you will get? Minus 20 volt plus 8.2. This is in kilo ohm. So I you will get in milliampere. So I dash you will get in milliampere because I am taking this to be in kilo ohm. I am taking this to be in kilo ohm. 8.2 kilo ohm into I dash plus 2.2 kilo ohm into I dash minus 20 is 0. So I dash is given by 40 volt divided by 10.4 kilo ohm. So I think this will be 3.85 milliampere. This is 3.85 milliampere. 3.85 milliampere. Now you have to find VTH. If you know I dash, now let's apply KVL in this loop. Call this as loop 2. So in loop 2, if you apply KVL, I'm taking this polarity to be plus minus. So start with here. So you will get 2.2K into 3.85 milliampere minus 20 volt minus VTH is 0. So VTH will be given by this is 2.2 into 3.85. So I think this value is, let's calculate this value. So this will be given by 2.2 into 3.85 minus of 20. You will get this much volt. I think this is approximately 8.5 minus, I'm writing the approximate value 20. So this is 11.5 volt. Approximate value is 11.5 volt. Yes or no? Plus or minus? I think you will get with minus sign. This will be with minus sign. Because this value is plus and this is minus 20. So you will get minus 11.5. Now we have to see what do you mean by minus value? Because till now we have calculated VTH to be positive. So when VTH is positive, you have this polarity. But when VTH is negative, you have to change the polarity. Clear? So we will write the actual polarity will be what? We will write this as minus plus and this magnitude is 11.5 volt. Now we have to calculate RTH also. Let's see what will be RTH. We have to calculate RTH also. So for RTH, voltage sources will be short circuited. So this voltage source is short circuited.
सर
Hmm.
सर करंट की डायरेक्शन वही रहेगी
Because I dash is positive, no? In when you are applying KVL, you can assume any direction. If current is positive, so it means that is your actual direction. So this is your actual direction of current because I dash is positive. Yes or no?
Yes, sir.
And from this actual direction, so this polarity will be plus minus. So if you apply KVL, VTH will be negative. So you have to see what will be the polarity. Polarity is important. So this is 8.2 kilo ohm. This will be 2.2 kilo ohm. Now this will be also short circuited. Voltage sources will be short circuited. Now you have to measure equivalent resistance between point 1 and 2. So what will be RTH? So RTH will be parallel combination 8.2 into 2.2 by
1.73.
8.2 plus 2. So I am taking approximately 1.7 K. Approximate value I am taking 1.7 K. So this is 1.7 K. So actual direction of current, if you see the single loop, this will be in opposite direction. Because if you want to show the actual direction of current, so this will be the direction of current. And I will be given by 11.5 volt divided by 1.7 K plus 1.3 K. This is 2 K. This much volt. This much milliampere, not volt. You will get this much milliampere. Is it clear?
Yes, sir.
Sir, it would be 3K, right?
It would be
3K,
Yeah,
sir.
1.7 plus 1.3. That would be 3.
okay. Okay. Just yes. Please.
8.3.
This will be 3 kilo ohm. So what will be the value?
0.8.
3.8, approximately 3.8 milliampere. Clear? So I think now you can easily apply Thevenin's theorem. Clear?
Yes, sir.
Sir,
Yes. Any doubt in Thevenin's theorem? Is it clear to everyone?
Yes.
Now we will see Norton's theorem. Next is Norton's theorem. Now we have Norton's theorem. So again, any two-terminal network, you should write a linear two-terminal network can be replaced by an equivalent an equivalent circuit consisting of a current source IN and parallel and and consisting of a current source IN in parallel and consisting of a current source IN and in parallel resistance RN. So now I'm considering a two loop network R1. This is R1, R2, R3. And this is RL. This will be V 1 and 2, and you have to find current IL. So what will be its Norton equivalent? Norton equivalent is you have to consider a current source IN and there is a parallel resistance RN. So this is Norton's equivalent between terminals 1 and 2. And then there is a load resistance RN. So this current is I. ठीक है? Is it clear?
सर
Yes,
RN
sir.
equivalent resistance है RN.
Yes, just like RTH, we have RN is same as RTH. Means you have to find equivalent resistance between terminals 1 and 2 by making independent sources turned off. So RN and RTH is same. We have to see what is IN and then RN is same as RTH. What is Norton's current? IN. We have to define what is IN. IN is called as short circuit current. This is short circuit current. Short circuit current means you have to short the terminal 1 and 2. Then see what will be the current through that path. RN. This will be R1. This is R2. This is R3. And this is short circuited. This will be short circuited. Now this current is defined as IA. This will be R3. And this is R1. So what will be IN here? For IN, you have to use the current division rule. Let's assume this current is I1. So what will be I1? I1 is V by equivalent resistance across terminals AB. So this is V by R equivalent across AB. Okay. So what will be equivalent? This is given by V by R1 plus R2 R3 by R2 plus R3. Okay. So this will be I1. And if you know I1, then apply current division at this node because you have to find IN. So from current division, IN is given by R2 by R2 plus R3 into I1. So this is the value of IN. So you know IN, short circuit current. And RN is similar to RTH. RN is same as RTH. Means you have to find equivalent resistance between terminal 1 and 2 when independent sources are turned off. So you can, same thing you can write for RN also. So because RN is exactly same as RTH, so I am not drawing the circuit again for RN. Just remove the, let's remove it. This is, it will be short circuited. So this is R1, this is R2, this is R3, 1 and 2. And this will be Rn. So Rn will be given by R1 R2 by R1 plus R2 plus R3. So this will be Rn. And once you know IN and Rn, what will be IL? IL from current division rule, you should apply current division. So this is Rn by Rn plus RL into IN. So this will be load current. Clear? So this is the Norton's theorem. ठीक है? Clear?
Yes, sir.
Now again take one example here.
Sir, please 1 minute.
हाँ.
Okay.
Let's take one example. I am taking same example again and again because you know the answer, but we are applying different theorem to calculate same value. This is 3 ohm, 6 ohm, 7 ohm, and this is also 7 ohm. Find out current I. So same thing, but you have to see the numerical value. Check karo. So equivalent, you know, this is Norton's current. This is Rn. Seven ohm. This is I. 1 and 2. So equivalent for IN. IN के लिए क्या होगा equivalent? Short circuit current. Let's sort. This is IN. So you should first find current I1. So I1 is, you have to see equivalent across AB. This is 12 volt divided by equivalent across AB. ठीक है? And this equivalent is, these two are in parallel. So this is 3 plus 6 into 7 by 6 plus 7.
29 by 4. 16 by
So
20.
this is 12 into 13. 81. 39 plus 42 is 81. 27. 52 by 27. Ampere. So that will be I1. So now apply current division at this node. So what will be IN? IN will be given by 6 by 6 plus 7 into I1. 52 by 27. 24 by 27 ampere. And this will be 8 by 9 ampere. So this is 8 by 9 ampere. ठीक है? And what will be Rn? Rn will be simply just remove the load resistance. This will be short circuited. So you can see 3 into 6 by 3 plus 6 plus 7. So this will be 9 ohm. So this is 9 ohm. Now current I is given by 9 by 9 plus 7 into 8 by 9. So this is 8 by 16. Again, you will get half ampere. Is it clear? ठीक है? So any doubt in this theorem?
No, sir.
So by drawing the Norton's equivalent circuit, you can find the current and then you should find the voltage drop across different elements. Clear? So we talked about superposition theorem, Thevenin's theorem and Norton's theorem. In next lecture, we will take some miscellaneous example. So let me first finish the different theorem part. And then in next lecture, we will take miscellaneous example, mixed type of problem. Okay?
Previous slide. Thank you, sir.
Maximum power transfer theorem. So let us consider any two terminal network. We have any two terminal network. And this is connected with some variable load. This load is variable. And you have to see that this network will deliver maximum power to the load when load resistance is equal to the Thevenin resistance of the network delivering the power. So you should write the maximum power will be delivered to the load when the load resistance of the network, when the load resistance is equal to the Thevenin's resistance of the network delivering the power. Means you will see for maximum power, RL should be equal to Thevenin's resistance of the network delivering the power. So let's draw its Thevenin's equivalent across points 1 and 2 will be given by, I'm considering a voltage source VTH, and there is a series resistance RTH. This is 1 and 2. This will be RL. What is current in this? Let's see, this current will be I. So I is given by VTH by RTH plus RL. So what is the power delivered to the load resistance? Load resistance is P, and that is given by I square RL. And this will be VTH square RL by RTH plus RL whole square. So if you want to see for maxima minima, we have to see that this dP by dRL should be 0. Let's differentiate with respect to RL, because RL is variable, and then we have to see for what value you will get the maxima. So this will give you VTH square is common. RTH plus RL divided by whole square. This will be power 4. So from here, you will get RTH plus RL whole square is 2RL RTH plus RL. And this will give you RL is RTH. RL is equal to RTH. And you will see its second derivative will be negative. Second derivative of dP by, if you take further derivative, that will be negative. So at RL is equal to RTH, you will get maximum value. And this maximum value is given by VTH square RL is RTH by 4 RTH square. So maximum value is VTH square by 4 RTH. This will be the maximum power delivered to the load. And if you plot P versus RTH by RL, then you will see, you will get this type of curve. This value is 1, and this corresponds to the P maximum. and this P maximum is equal to VTH square by 4 RTH. So you should know the statement of maximum power transfer theorem also, that if you have any two terminal network, maximum power will be delivered to the load when load resistance is equal to the Thevenin's resistance of the network. So you have to replace the network by its Thevenin's resistance. So at that particular value, you will get the maximum power will be delivered to the load. Clear?
Yes, sir.
So note it down.
सर
Hmm.
सर ये नीचे पी मैक्स वाला एक बार फिर से समझाओगे? लास्ट जो है लास्ट.
This graph,
यस सर.
I'm telling you, if you plot this P is what? VTH square RL by RTH plus RL whole square. And for maximum minima, you have to put this to be 0. And if you see second derivative, if you take second derivative, this will be negative. I'm using the maximum minima condition. So at this particular value, this power will be maximum. And then if you put the value of RL is equal to RTH, you will get the maximum value. Because you are getting that RL is equal to RTH, power delivered to the load is maximum. So what will be maximum power? So just put RL is equal to RTH.
समझ गए. यस.
So this is VTH square by 4 RTH. So if you have to find in this network, what is the maximum power delivered to the load? So that is simply VTH square by RTH. So this is again a application of Thevenin's equivalent network. Okay?
यस सर.
Means whenever you have to see at for what value, you have to find Thevenin's equivalent. And what will be the maximum power? VTH square by 4 RTH. Clear? So let's see one more example. This is the application of again Thevenin's theorem. So you have to see for what value of RL maximum power will be delivered to the load. And I am taking this particular circuit. This is 10 volt. So this is 4 ohms. This is 6 ohm. This is 1 ohm. This is 4 ohm. And this is the RL. Find the value of RL. Find the value of RL for which the maximum power will be delivered to it. So you have to draw its Thevenin's equivalent. Let's say this is terminal 1 and this is terminal 2. Yes or no? So what will be equivalent? Thevenin's equivalent will be VTH RTH across 1 and 2. So what will be RTH? Let us first see RTH. And you should also find the maximum power delivered to it. And also find the maximum power delivered to the load. So what will be equivalent between 1 and 2? Let's sort this. This will be short circuited. Now, this is no, this is open circuited. This will be open circuited. This is 0.1 and 2, and this is RTH. You have to see equivalent resistance between these two. So this is 4 ohm and this is 6 ohm. This is 1 ohm. This is 4 ohm. So what will be RTH? Across 0.1 and 2. So if you are considering this to be 0.1 and this to be 0.2. This is 0.1, this is 0.2. Now let's take this point to be let's check. Now this is short circuited. So I am taking this to be 0.2. So this is also 0.2. This point is 1. This is 1. This is short circuited. So this point is 2. Now I am taking this point to be 3. Okay. So let's see, another point is 3 here. Now connect the between 1 and 2. 6 ohm is connected. This is 6 ohm. So I have used this resistance. Then between 1 and 3, 1 ohm is connected. 1 ohm is connected. Then 2 and 3, 4 ohm is connected. 4 ohm is connected. And again, 2 and 3, 4 ohm is connected. 2 and 3, so I am taking, let's see, this is also a 4 ohm, or let's connect here another 4 ohm, and you have to see equivalent between these 2 points, RTH. So see what will happen. So these two are in parallel. So equivalent will be 2 ohm. Then this is in series 3 ohm, and then it is in parallel. So what will be RTH? RTH will be 6 ohm plus 6 ohm parallel combination of what? 1 ohm plus 2 ohm. So this is 6 into 3 by 6 plus 3. So this will be 2 ohm. Is it clear? So at this particular of load resistance, when RL is equal to RTH, maximum power will be delivered to the load. Is it clear?
Yes, sir.
So we have discussed the different theorem. Now in next lecture, we will focus on miscellaneous example, and I will also introduce the Wheatstone bridge circuit, because that is the basic concepts. We can sometimes we have to use the concept of Wheatstone bridge. So we will talk about Wheatstone bridge, and now we will focus on the miscellaneous example, mixed type of problem. So that will be the last lecture, because network analysis is the introductory lectures for electronics. So these are the theorems. One
Can
part
you
is
explain
Wheatstone bridge.
again the last step?
Which one? Equivalent
Sir,
resistance.
yes, sir. So how we can
Equivalent
write
resistance.
1 ohm plus 2 ohm? That step.
No, just see if these two are in series or parallel.
Yes, sir.
Parallel. So when it is in parallel, this is 1, this is 2, this is 1 ohm, this point is 3. Now this is 2 ohm. Now tell me. These are the 2 points where you are measuring the equivalent. So these are in series or parallel?
Parallel, sir.
नहीं, ये 1 और 2 देखो, ये सीरीज में है कि पैरेलल में है?
ये series में.
सीरीज में है ना. कोई भी करंट फ्लो होगा तो सेम फ्लो होगा. सो 1 and 2 दे आर इन सीरीज, तो इनका इक्विवेलेंट 3 हो गया, और फिर ये इसके पैरेलल हो जाएगा.
Yes, sir.
ठीक है?
Got it.
ओके. यस, एनी डाउट in today's lecture?
Sir, can you please show the slide number 15? Thank you, sir.
Okay. Is it clear to everyone?
Yes, sir.
Yes, sir.
So in next lecture we will focus on miscellaneous example. ठीक है? तो आप एक बार रिवाइज करके आना. We will give you the problems on different theorem and mixed type of problem also. ठीक है? फिर कल मिलते हैं. Clear?
Okay, sir.
Thank you, sir.
Okay. Thank you. Thank you
Thank
everyone.
you, sir.
The reference book, sir.
Yes.
The reference book.
Book you want?
Yes,
I
sir.
think class notes is sufficient. Don't follow
Okay,
any
sir.
book for this. Class notes is
Okay,
sufficient. Especially in electronics,
Sir,
don't
please
follow
last
any
slide.
books.
Okay, sir. Thank you, sir.
सर
Hmm.
सर जैसे एक कॉम्प्लेक्स सर्किट है ना, इसमें पता नहीं लगता सर पैरेलल कैसे है, सीरीज पे कैसे है.
अब वो तो एग्जाम्पल से ही कर सकते हैं.
सर वो तो है, पर सर कॉम्प्लेक्स में थोड़ी दिक्कत है, मतलब पैरेलल
नहीं,
सीरीज.
तो देखो इस स्टेज पे बहुत ज्यादा कॉम्प्लेक्स तो मैंने, अब आप IIT जी वाले लेवल पे मत जाओ. क्लास में मैं जितना करा रहा हूं इस लेवल पे इससे डिफिकल्ट नहीं पूछेंगे. ठीक है? अब वो तो ठीक है, मैं
Yes.
कितना भी कई लूप बना के उसमें पूछूं तो कॉम्प्लेक्स तो किया जा सकता है. प्रॉब्लम्स तो बहुत सारे कॉम्प्लेक्स किए जा सकते हैं. बट आपकी क्या रिक्वायरमेंट है? आप IIT जी की तो प्रिपरेशन नहीं कर रहे हो, है कि
Yes.
नहीं?
Yes.
तो जो एग्जाम की रिक्वायरमेंट है, कॉन्सेप्ट क्लियर है. क्वेश्चन की डिफिकल्टी लेवल कुछ भी हो सकती है, बट आपके एग्जाम की जो रिक्वायरमेंट है वो मैं करा रहा हूं.
यस सर।
ठीक है, और आप प्रीवियस ईयर करो, लास्ट 20 ईयर्स के जो भी क्वेश्चंस है वो आप सॉल्व करो, उससे आपका कॉन्फिडेंस बिल्डअप हो जाएगा। ठीक है,
यस सर।
चलो ओके, थैंक यू,
Thank you, sir.
थैंक यू,
Thank you, sir.
थैंक यू।
Thank you, sir.